Hey everyone, today I want to talk about exact trigonometric values. It should say approximate there too, but exact is really where I want to go with this video. So when we talk about trig values, think the unit circle, think radians, think degrees, all that jazz. Trigonometric values can be either exact or approximate. Exact values come directly off the unit circle. Think the unit circle and think if you were to identify one particular trig function, typically cosine or sine, but we can go a little deeper here too, and finding out the value of what that actual trig function is. Remember, cosine is x values. So if I ask for cosine of a particular angle measurement, you should be able to give me a number. Now remember, the unit circle is only built off of 5 numbers in terms of the measurements that we know of. 0, 1, 1/2, root 2 over 2, and root 3 over 2. So you should be able to give me which one I'm looking for based on cosine, sine, tangent, or the other 3 functions. So the scary part about this is questions like this typically say no calculator. Big, like that. Bold. Probably in yellow. Maybe not yellow, but big like that. Because you're not really supposed to use a calculator for this, because you should be able to use either your memorization of the unit circle, special right triangles, or just your identification methodology of the unit circle. Example 1. Find the exact value of cosine of 0 degrees. Let's think about this for a second. We have our unit circle. I want to know the x value at the 0 degree mark. Well, the x value at the 0 degree mark is 1. Because if we think about where x is when it's 0 degrees, we go from the center, or the origin of the circle, all the way over to the side. So our answer is 1. Example 2. Find the exact value of sine 150. Well, again, 150 is a measurement that is on the unit circle. So let's think about this together. 150 degrees is certainly past the 90 degree mark, right? And it is almost all the way down back to 180. Now, what is that value exactly? Remember, we're looking for a y value. The sine value of 150 degrees is 1/2. Again, exact values, don't let them scare you. If you have a good understanding of the unit circle, you're looking good. Example 3. Find the exact value of secant 135. This is where it gets a little bit more challenging. So what I really need to do here is I need to find out what is the base trig function from secant, or what's its inverse. Well, we know secant's inverse is cosine. So let's think about what cosine's value at 135 is, and then apply it to our secant ratio. So cosine of 135 degrees is negative root 2 over 2. That's the cosine value at 135 degrees. Because remember, 135 degrees ends up in quadrant 2. Cosine values are negative in quadrant 2. So that's our cosine value at 135 degrees. But let's recall what secant is. If cosine is x, secant, being its inverse, is 1 over x. So what we're going to do here is we're going to replace this x value with our negative root 2 over 2 and simplify as necessary. So what I have here is 1 over negative root 2 over 2. Now, we don't divide fractions. We multiply by the reciprocal. So let's write it out sideways to make it flow a little bit nicer for us. This is all going to be 1 divided by negative root 2 over 2. I like this marker a lot. It's smooth. But we're going to multiply by the reciprocal. Negative 2 over root 2. Well, 1 times that just becomes negative 2 over root 2. And here is where we have to do just a little bit more work. I have to rationalize the denominator because I am not allowed to have a radical in the denominator. So let's do that. Multiply by root 2 and root 2. That's supposed to be a 2. Then I'm going to have negative 2. I want to make sure you can see. You can't. I'm going to go up here. Negative 2 root 2 over 2. Well, the 2's cancel, but the negative stays. The secant value at 135 degrees is negative root 2. Let's finish up. Example 4. Find the exact value of cotangent of negative 225. Now, I'm going to say don't let this fool you, but I'm going to say it in the wrong way. Don't let this fool you. This is a really hard problem. And here's why. If you forgot what a negative angle looks like, you're totally screwed because you're going to go the wrong way. Remember, negative angles start from our initial side and go clockwise. So we are not going 225 around counterclockwise. I need to go around the other way. It might be easier, in fact, to find the coterminal angle first and then work our way. So if I'm going to go 225 degrees, I would end up in quadrant 2. But if I found the coterminal angle, it's going to be the same value either way. So what's coterminal to negative 225? 135. So cotangent of negative 225 really needs to be the same as cotangent of 135. Let's do it both ways and see what we get. So cotangent is the inverse of tangent. Now, it might be easier to think of it like this. Remember that the ratio for tangent is y over x or sine over cosine. Cotangent being the inverse, it's just the reverse. So cotangent is x over y, which is cosine over sine. So if we know the measurement or the ordered pair at 135 for xy, we're in good shape. Kind of like the first problem we did here in example 3. It's a little bit of a giveaway. That was not intended. That was purely coincidental. So we know that at 135 degrees, the ordered pair is going to be, and I'm going to go up here, it's going to be negative root 2 over 2, comma, root 2 over 2. Now remember, 135 degrees counterclockwise is in quadrant 2. Negative x values, but positive y values. We know we're in the right spot. Think of it again, too, if I were to go around the other way. Negative 225 is certainly from the initial side all the way around to the terminal side, but I'm going 45 more degrees up. If I were to go this way, it's the coterminal side. Exactly what I'm looking for. So we can look for the coterminal angle instead to get rid of those nasty negatives. Moving back to what we need. I need cotangent at 135. This is the point at 135. So cotangent is just x divided by y. X divided by y. So let's do that the long way. This is negative root 2 over 2 divided by root 2 over 2. Again, we don't divide fractions. We multiply by the reciprocal. So this is going to be negative root 2 over 2 times 2 over root 2. Everything's going to cancel, except for what? The negative sign, which is negative 1. So my value at cotangent negative 225 is negative 1. Okay, so this is the better part, the funner part, the way more funner part. And no, I'm not stopping this video to edit it out. When I ask you for the approximate value of the trigonometric function, it's always going to say use your calculator. And here's why. Because these values are not easily attainable off of the unit circle, just from an eyeball standpoint. I need some kind of technology to help us find the exact value, the closest number that we can find to that value. Let me talk about it. Example 1 says to find the approximate value of cosine 78. All right, well, let me do a little drawing here on what cosine 78 is really asking us for. Let's talk about the first quadrant of the unit circle, right? So this point here is 1, 0. 1 is cosine of 0 degrees because this is the 0 degree angle. Cosine is x. That's 1. This value here is 0, 1. This value here is at cosine of 90 degrees because this is the 90 degree angle. So cosine of 90 is 0. Cosine of 90 is 0. Cosine of 0 is 1. I know. But basically what I'm doing is I'm just trying to find where the x value is along this continuum. The x value at cosine of 0 degrees, this point right here where my finger is 1. The x value or cosine value at 90 degrees is 0. Now, everything in between here, think from a horizontal standpoint, are x values. Well, it's got to be along this curve or arc somewhere. So 78 is far closer to 90 than it is to 0. So we're figuring out that it's probably somewhere in this vicinity maybe? Well, if that is 0 and the continuum goes to 1, it's going to be probably close to 0. Not exactly 0, but it's going to be a decimal close to 0. So let's find out. All we're doing is we're going to press cosine 78 in the calculator. Make sure you're on degrees though. Going to ignore what that was. Cosine 78 is 0.21 if I'm rounding to the hundredths place. And now that makes sense for us because 0.21 is pretty close to 0. Not exactly a quarter of the way through, but it's pretty close. And that makes sense for where 78 degrees lies on this continuum, right? So we're really trying to use the calculator to help us find out where is that point or where is that part of my ordered pair or x value on this continuum. Let's move on. Example 2. Find the approximate value of sine 95. Same exact idea. What's the y value when we have a 95-degree angle? I'm not going to draw it because Titan told me that that last drawing sucked. Thanks, pal. Sine of 95, if I'm rounding to the hundredths place, we're going to really want to round it to the thousandths place. You'll see why in a second. This is going to be 0.996. Now, why is it so close to 1? Well, sine of 90 degrees is 1. So sine of 95 degrees, which is a little bit past the 90, it's at an obtuse angle, is going to be less than 1, but not much because it didn't go far down on the circle. So we got 0.996 there. Let's keep going. Find the approximate value of secant 0. Well, kind of like when we did the exact values, I need to find the inverse's value at 0 and then apply the new ratio to that. So remember, we know that cosine is x, and I didn't want to write over that. I don't really want to edit that out. Cosine of x is the same thing as secant's 1 over cosine. Right? So we know the cosine x is a value, and secant is 1 over cosine. So let's find the cosine value at 0 first. Well, we kind of just did that. Cosine of 0 degrees is 1. Now, this secant nonsense here is 1 over whatever the cosine value is at that value. So I'm going to plug in the 1 for the cosine. So secant of 0 degrees is also 1. Let's finish this part up. Find the approximate value of tangent of negative 90. Now, tangent of negative 90 is going to be a little bit trickier because I need to make sure I put that negative sign in. Sometimes, when we put values in, we get an undefined result because there is actually no value there, or because we're going to be dividing by 0. Let's see if that's one of those times. Tangent of negative 90. Wow. It's like I'm a mind reader. You get error domain. And here's why. Tangent values at the axis points, or at least on the vertical axis, is really ugly. And here's why. Tangent is sine divided by cosine. Well, remember we're doing negative 90, which means we're going to have to go around the other way. I certainly could have done tan of 270, but negative 90 is a pretty easy value to do. Tangent of negative 90 is going to be this point right here if I'm going clockwise in the unit circle. Well, this point right here is 0, negative 1. X, y. Cosine, sine. But if I'm going to replace 0 and negative 1 for my values here, what is it really going to give me? Well, the sine value is y, so this is just negative 1. But cosine 0. There is no defined value at tangent of negative 90 because I'm going to be dividing by 0. Now, for those of you that don't remember, dividing 0 by anything is 0. But when I divide into 0, that's bad, bad land. It's undefined. You're going to write that. That's the answer. Let's finish up. This blooper tape is going to be amazing when it comes out. Things to remember about this video. Number 1, exact values mean you really, really need to know and use and just love the unit circle. Because exact values means you're really just pulling values from the unit circle. are values that we know, are values that we love. Number 2, approximate values, way easier. If it's sine or cosine or tangent, use the calculator. If it's cosecant, cotangent, or secant, just tell me what the inverse value is at that degree measurement and use your ratios to figure out the other part. Number 3, be really careful what it says. Sometimes it's really simple to get exact and approximate mistaken. Clearly, the one thing it's going to be bolded in any question you see is no calculator allowed or use your calculator. That will be the giveaway on how to solve these problems. Bark to you, sir. He's not happy. See you next time.